Here's a question nobody asks. What color is invisible? Sounds stupid, right? But that's exactly the trap we fall into with black holes. We named them black because we couldn't see them, like a kid calling the dark scary because he doesn't understand it yet. But here's the thing that'll mess with your head. Black holes are actually the brightest, most radiant things in the entire universe. They scream with energy. They glow, some of them outshine entire galaxies. We just couldn't see it at first because we were looking with the wrong eyes. And that mistake, that one word, black, has fooled billions of people into misunderstanding one of nature's most beautiful tricks. And I get it. I really do. When you hear black hole, you picture this cosmic vacuum cleaner, right? This monster lurking in space, sucking up everything around it, killing light itself where all the rules break down, and nothing matters anymore. It's dramatic. It's scary. It makes for great movies. But it's also deeply, profoundly wrong in ways that matter. And not just wrong about physics. Wrong about how you think about endings, about darkness, about the things in your own life that seem impossible to escape or understand. Because here's what nobody tells you. That image of black holes as dead zones, as cosmic graveyards where physics goes to die, it's not just inaccurate. It's a tragedy of imagination. It robs you of understanding one of nature's most profound lessons, that destruction and creation are the same process wearing different masks. That what looks like an ending is actually the most violent, energetic, creative transformation in the entire universe. So let me tell you what this video is really about. You've been lied to about black holes, not maliciously, but through the limitations of language and the human tendency to simplify things until they're digestible but wrong. And the lie isn't just about objects in space. It's about how we frame the unknown, how we deal with boundaries, how we understand the relationship between what we can see and what's actually there. This video is going to show you that black holes aren't endings. They're transformation engines running at maximum capacity. They don't destroy information. They scramble it into forms we're only beginning to decode. They don't suck like vacuum cleaners. They organize space and time into the most extreme geometry the universe allows. And here's the reframe that changes everything. The blackness you've been told about isn't a property of the black hole itself. It's a horizon of our ignorance. It's the boundary where our ability to see stops, not where reality stops. Once you cross that mental barrier, everything shifts. You stop seeing black holes as monsters and start seeing them as nature's most honest teachers about impermanence, about information, about the ultimate creative act of letting go and transforming into something else. And look, I know most science content just gives you facts to memorize. The mass of this, the radius of that, how many solar masses fit in the supermassive black hole at the center of our galaxy. That's fine. That's useful if you're taking a test. But we're not here for trivia. We're here because the universe's darkest objects have something to teach us about light, because its most destructive forces are the ones seeding new galaxies. Because the boundary between knowing and not knowing, that event horizon of human understanding, is where all the interesting stuff lives. You're going to walk away from this not with more facts to impress people at parties, but with a fundamentally different relationship to uncertainty, to endings, to the stories you tell yourself about what's permanent and what's not. So let's start where all good physics starts, with a story. Not an equation, not a diagram, a story about what actually happens when matter meets one of these things we've been so wrong about. Picture yourself as a particle of gas. You're just floating out there in interstellar space, minding your own business. You're cold, just a few degrees above absolute zero. You're lonely, there's nothing around you for light years. You're barely moving, just drifting in the almost nothing of space. And then, somewhere nearby, a black hole opens its gravitational hand. Now, here's where Hollywood gets it wrong. You don't fall straight in like water down a drain, that's the cartoon version. Instead, you start to orbit. Because here's the thing about gravity. It doesn't pull you toward the center unless you're coming in from directly above. If you're coming in at any angle at all, which you almost certainly are, you go into orbit first. So you're orbiting now, and you're not alone. There are billions, trillions of other particles out here with you, all of you circling this invisible point in space, all of you slowly spiraling inward. You've joined what we call an accretion disk. It's like a spiral staircase, except the stairs are made of gas and dust and shredded stars, and there is no bottom floor, just a one-way door in space and time. And here's where it gets beautiful. Really genuinely beautiful in a way that made me sit up the first time I understood it. You're rubbing against all those other particles now. Friction. Just simple, ordinary friction, the same thing that makes your hands warm when you rub them together. Except you're not moving at normal speeds. You're orbiting at a significant fraction of the speed of light. The friction isn't gentle. You start heating up. First you're warm, then you're hot, then you're thousands of degrees, then millions. And when you heat up, you glow. That's just physics. Heat means motion at the atomic level, and moving charges radiate electromagnetic waves. First, you're glowing in infrared, invisible to human eyes, but warm to the touch if anyone could touch you. Which they can't because you're in space and also you're about to become millions of degrees. Then visible light, you're red, then orange, then white hot. Then you push into ultraviolet, then X-rays, then gamma rays. You've gone from being invisible, from being nothing basically, just a cold particle in the dark, to becoming one of the brightest things in the universe. And you're not alone. Every particle in that accretion disk is doing the same thing. The whole disk is glowing, screaming light into space from the sheer violence of matter trying to spiral into oblivion. And the black hole? The actual black hole at the center, with its event horizon and its singularity, it's still black technically. Still invisible. But it's wearing this brilliant crown of light, an accretion disk so luminous it can outshine the combined light of 100 billion stars. We've found black holes surrounded by so much glowing matter that we can see them from across the visible universe. Quasars, the brightest objects we know, powered by the blackest objects we know. Think about that for a second. The darkest thing becomes the source of the brightest thing, not despite its darkness, but because of the intense gravity that makes it dark in the first place. This is the story of how constraints create beauty. The very thing pulling you toward oblivion is the same thing making you radiate with energy you never knew you had. The tighter the spiral, the brighter you burn. And I don't just mean physically. I mean this as a metaphor you can actually use. When you're under pressure, when life is compressing you into tighter and tighter orbits, when you feel like you're spiraling toward some kind of ending, that's when you're most visible. That's when you're putting out the most energy. That's when you matter most to the universe around you. But here's what bothered me for years, and maybe it'll bother you too once you think about it. If all this light escapes, if the accretion disk is radiating away all this energy, what actually makes it into the black hole? What crosses that final boundary, the event horizon, and goes somewhere we can never see or retrieve or understand? And when it does cross, does it really disappear, or does nature have one more trick up its sleeve? This is where we run into the biggest fight in modern physics, and I mean a real fight. Physicists yelling at each other at conferences, bets being made, reputations on the line. The kind of scientific drama that most people don't realize happens because we have this image of scientists as these calm, rational people who just follow the evidence wherever it leads. Let me tell you about this fight. It's called the information paradox, and it's been raging since the 1970s. Imagine I write a secret message. I seal it in a box. I throw that box into a black hole. Common sense says, message gone forever. Einstein's general relativity, the theory that predicts black holes in the first place, agrees. Nothing comes back out. The event horizon is a one-way membrane in space-time. Information goes in, never comes out. Story over. But then quantum mechanics walks into the room and says, wait, hold on, information can't be destroyed. That's a fundamental law. Those words you wrote, the specific arrangement of atoms in that box, the exact quantum state of every particle, all of that still exists somewhere. It has to. The universe doesn't delete information. It can scramble it, hide it, transform it beyond recognition, but it can't erase it. So now we have two fundamental theories, both tested to absurd precision, both trusted by every physicist on Earth, screaming opposite things at each other. Relativity says information is destroyed. Quantum mechanics says it can't be. And they can't both be right. This isn't some abstract puzzle about angels on pinheads. This is about the basic consistency of physical law. If information can be destroyed in a black hole, then quantum mechanics is wrong. And we need to throw out decades of physics that have given us semiconductors and lasers and MRI machines and everything else that depends on quantum theory being correct. But if information can't be destroyed, then we don't understand black holes at all. And general relativity, which has passed every test we've ever given it, from GPS satellites to gravitational waves, is incomplete in some fundamental way. Stephen Hawking made this worse, or better, depending on how you look at it. In 1974, he was working through some equations, just playing around with what happens when you combine quantum mechanics and general relativity near an event horizon, and he found something so disturbing that the physics community thought he'd lost his mind. Black holes evaporate. They glow. They give off radiation. Here's how it works, and this is going to sound insane, but I promise you it's real. Verified physics. Quantum mechanics says that empty space isn't really empty. It's seething with activity. Particle-antiparticle pairs are constantly popping into existence out of nothing, existing for a tiny fraction of a second, and then annihilating each other. Normally, this happens so fast that you never notice. It's just the quantum vacuum doing its thing. But at the edge of a black hole's event horizon, something wild happens. A particle-antiparticle pair appears. One of them falls into the black hole, the other escapes. And here's the kicker. From the outside, from our perspective, it looks like the black hole just radiated a particle. It gave off energy. It lost mass. Do this enough times, and quantum mechanics says you have to do it, constantly at the event horizon, and the black hole slowly evaporates. Over trillions upon trillions of years, yes, but it evaporates. It's mortal. What seemed eternal is temporary. What seemed like an immortal monster has a lifespan. A black hole isn't a cosmic gravestone. It's a candle burning down. When Hawking published this, people freaked out, because now the information paradox gets even worse. Not only does stuff fall into black holes, but eventually the black hole itself disappears. So where did the information go? Did it burn up in the Hawking radiation like a letter in a fire? Is it encoded somehow in the pattern of that radiation, scrambled beyond recognition but technically still recoverable if you measured everything perfectly? Or is it just gone? For 30 years, Hawking said, it's gone, destroyed. Quantum mechanics is wrong inside black holes. We need new physics. He made a famous bet with another physicist, John Preskill, over this. And then, in 2004, at a conference in Dublin, Hawking stood up and said, I was wrong. I lost the bet. The information probably does escape. We just don't know how yet. He gave Preskill a baseball encyclopedia as the prize. The information in the encyclopedia was supposed to represent the information that doesn't actually get destroyed. It was Hawking's way of admitting that the smartest person in the room had been wrong for 3 decades. Now, this story isn't about physics equations. I mean, it is, but that's not why I'm telling it to you. I'm telling you because it's about the terror and relief of uncertainty, about how the smartest person in the room can be wrong for decades and still keep working on the problem, about how the universe doesn't owe us neat answers just because we really, really want them. And here's why this matters to you, sitting here nowhere near a black hole, because you've got black holes in your own life. Not literal ones, obviously, but places where information seems to disappear, relationships that ended without closure, efforts you put in that seemed to vanish without a trace, versions of yourself that you were once completely, and now can't find anywhere. And you've probably told yourself the same story we told ourselves about black holes for 50 years. It's gone, it's lost, it's destroyed. I'll never get it back. I'll never understand what happened to it. But what if that's wrong? What if the information, the essence, the meaning, the value of what you put in didn't disappear? What if it's just transformed into a form you can't recognize yet? Scrambled, yes. Encoded in patterns you haven't learned to read, but still there, still real, still part of the system. I'm not saying this to make you feel better with false comfort. I'm saying it because physics, real physics, hardcore mathematics is telling us that nature doesn't delete things, it transforms them. And if that's true for the most extreme conditions in the entire universe, maybe it's true for you too. Okay, let's step back. Let's talk about the name itself. Black hole. Where did it come from? Why do we call it that? The term was coined in 1967 by a physicist named John Wheeler. Before that, people called them frozen stars, or dark stars, or Schwarzschild singularities, after the guy who first found them in Einstein's equations. But Wheeler wanted something catchier, something the public could latch onto. And black hole worked. It was mysterious. It was ominous. It stuck. But here's the problem. It's a terrible name. It's like calling the ocean empty because you're standing on a beach and you can't see the fish. It describes the limitation of the observer, not the nature of the thing itself. Black holes aren't black. They're invisible at the event horizon, yes, but that's because light can't escape from inside. That's a very specific property. It's about the behavior of light in curved space-time, not about the object being dark or dead or empty. Just outside the event horizon. Chaos. Brilliance. Matter heated to temperatures that would make the center of the sun look cold. Jets of particles shooting out at 99% the speed of light, powered by magnetic fields so strong they twist space-time itself. Gravitational lensing bending the light from stars behind the black hole into perfect rings. Einstein rings, we call them. And they're some of the most beautiful structures in astrophysics. The blackness is where our vision stops, not where reality stops. And that distinction changes everything. It means the scariest, most mysterious thing in the universe is actually just the edge of what we can currently see. The monster isn't the black hole. The monster is our assumption that invisible equals empty, that what we can't measure doesn't matter, that the boundary of our knowledge is the boundary of what exists. And here's the paradox I want you to sit with. The brightest objects we've ever detected, quasars, blazars, active galactic nuclei, are all powered by the blackest objects we know. Darkness and light aren't opposites here. They're not enemies. They're dance partners. The black hole's gravity creates the conditions for the accretion disk to radiate. The radiation carries away energy, allowing more matter to fall in, feeding the black hole. It's a feedback loop, a cycle. Creation and destruction wound together so tight you can't separate them. This happens in your life too, whether you notice it or not. The failures, the endings, the dark periods where you can't see what's next, those are often the times when you're putting out the most light for the people around you. When you're forced into constraint, into pressure, into situations with no easy exit, you heat up, you radiate, you become visible in ways you weren't before. I'm not romanticizing suffering. I'm not saying pain is good. I'm saying that the physics of extreme situations, whether it's matter spiraling into a black hole or you spiraling through a period where everything feels like it's collapsing, creates conditions for transformation that don't exist in comfort. Now let me tell you about something that's going to sound like science fiction, but is actually just science. Gravity. You think you know what gravity is. You learned it in school. Gravity is the force that pulls things together. Massive objects attract each other. The Earth pulls you down. You pull the Earth up, though your mass is so small compared to Earth's that it doesn't matter. Newton figured this out with an apple or whatever. That's wrong. I mean, it's useful. It's a good enough approximation for most things. If you're building a bridge or launching a satellite, Newtonian gravity works fine, but it's not what's actually happening. Einstein figured out what's actually happening, and it's so much weirder and more beautiful than forces pulling on each other. There is no gravitational force. Gravity isn't pulling you down right now, the floor is pushing you up. Here's the real picture. Mass curves space-time. Imagine space-time as a fabric, a rubber sheet stretched flat. When you put a massive object on it, a planet, a star, a black hole, the fabric curves, dips down, creates a well. Now, if you're moving through that curved space-time, you follow the straightest possible path, a geodesic we call it. But because the space itself is curved, that straight path looks curved to someone watching from outside. You're not being pulled toward Earth. You're following a straight line through curved space-time, and Earth's surface keeps getting in the way. You're trying to fall constantly along your natural path through space-time, and the floor is accelerating upward to stop you. That's why you feel weight. That's why your feet press into the ground. The ground is pushing you away from your natural trajectory. Black holes take this to the absolute extreme. They curve space-time so severely that the straight lines, the paths you'd naturally follow, circle back on themselves. There are orbits around black holes where light itself just goes in circles forever, trapped not by a force but by the geometry of space. And time, oh, this is where it gets really strange. Time slows down in curved space-time. The stronger the gravity, the slower time passes. Near a black hole, time crawls. At the event horizon, from the perspective of someone watching from far away, time stops completely. This isn't philosophy. This is measured, verified reality. If you had a friend falling into a black hole and you were watching from a safe distance, you would never see them cross the event horizon. Ever. They'd get dimmer and dimmer, redder and redder, their light stretched out by the extreme gravitational field. But they'd be frozen there forever in your reference frame, stuck at the boundary like a photograph. But from their perspective, they cruise right through. Nothing special happens at the horizon. They don't even notice it. It's only later, as the tidal forces, the difference in gravitational pull between their head and their feet, start to rip them apart, that they'd realize they've crossed a one-way boundary in space-time itself. Two realities, both true, neither complete. What you see depends on where you stand. The boundary between them isn't a disagreement about facts, it's a feature of relativity itself. Different observers, in different states of motion or different gravitational fields, experience different flows of time. This should bother you. It should make you uncomfortable, because it means that truth itself isn't absolute. It's observer-dependent, and that's not philosophy. That's physics. Tested, proven, real. Think about what that means for your life. How many times have you been in conflict with someone because you experienced the same event differently? You remember it one way, they remember it another, and instead of recognizing that you're in different reference frames, seeing the same space-time event from different perspectives, you assume one of you is wrong. One of you is lying, one of you didn't pay attention. But black holes teach us that multiple contradictory perspectives can all be true simultaneously. The person falling in crosses the horizon. The person watching never sees them cross. Both are correct. The universe doesn't pick sides. We touched on this earlier, but I want to go deeper because this is where black holes stopped being eternal and became mortal, and that shift changes everything. For most of human history, we've been obsessed with permanence. We build monuments, we carve our names in stone. We want to create things that last forever, or at least outlast us. And when we discovered black holes, we thought we'd found the ultimate permanence. Objects so powerful that nothing, not even light, could escape. Cosmic fortresses, eternal prisons. But quantum mechanics said, nope, even black holes die. Here's the mechanism again, in a bit more detail. The quantum vacuum empty space isn't actually empty. It's filled with fluctuating fields. These fields occasionally create particle-antiparticle pairs out of nothing. This sounds like magic, but it's allowed by the uncertainty principle. Energy can be borrowed from the vacuum as long as it's paid back fast enough that you can't measure the violation. Normally, the particle and antiparticle appear together, exist for a tiny moment, and annihilate back into nothing. The energy gets paid back, the books balance. But at an event horizon, one of the pair can fall into the black hole before they reunite. The other escapes. And now the books don't balance. The escaping particle is real. It has positive energy. The one that fell in from a certain point of view has negative energy. The black hole's mass decreases. This happens constantly, at every point on the event horizon. The black hole is leaking mass as Hawking radiation. Slowly, incredibly slowly for large black holes. But inevitably, a black hole the mass of the Sun would take 10 to the 67 years to evaporate. That's a 1 with 67 zeros after it, way longer than the current age of the universe. But a small black hole, one the mass of a mountain, that would evaporate in a fraction of a second, exploding in a burst of radiation. What seemed eternal is temporary. What seemed immortal has a lifespan. Everything that concentrates energy eventually disperses it. Everything that creates order eventually succumbs to entropy. Even the most extreme objects in the universe are just temporary configurations of energy, waiting their turn to dissolve back into the background hum of space-time. And here's the emotional weight of this, the part that hit me when I really understood it. This applies to everything. Stars die, galaxies disperse, solar systems break apart. Even atoms will eventually decay given enough time, and space itself, the fabric of the universe, might eventually decay into something we can't even imagine. The universe isn't building toward permanence. It's not creating eternal structures. It's dancing toward equilibrium, toward maximum entropy, toward a state where energy is spread so evenly that nothing interesting can happen anymore. And black holes, the densest objects we know, are just one step in that dance. This isn't depressing, or it doesn't have to be. It's liberating, because if nothing lasts forever, if even black holes are temporary, then you're off the hook. You don't have to build something eternal. You don't have to be permanent. You don't have to solve everything or fix everything or hold on to everything. You're allowed to evaporate slowly into something lighter. You're allowed to radiate energy and get smaller. You're allowed to transform completely into a form that doesn't even resemble what you were. That's not failure. That's physics. Okay, now I want to talk about something that sounds completely insane but is backed by serious, real mathematics: the holographic principle. When physicists tried to calculate how much information a black hole can contain, how many bits, essentially, how many yes or no questions you'd need to completely describe everything inside, they ran into something shocking. The amount of information isn't determined by the volume inside the event horizon. It's not about how much three-dimensional space is enclosed. It's determined by the surface area of the horizon itself, the two-dimensional boundary. Think about a sphere, any sphere. The bigger it is, the more volume it has inside, right proportional to radius cubed. But a black hole doesn't work that way. Its information capacity grows with the surface area, proportional to radius squared, like all the information about what's inside is somehow encoded on the skin, on the boundary, on the two-dimensional surface. This is exactly how a hologram works. A flat image, two-dimensional, containing three-dimensional information. You look at a hologram and you see depth, you see layers, you see objects that appear to have volume, but it's all encoded on a flat surface. So black holes are holograms? Kind of. The information about their interior is encoded on the event horizon. And then someone asked the obvious question: if this is true for black holes, is it true for the entire universe? Are we, three-dimensional beings walking around in three-dimensional space, actually just information encoded on a distant two-dimensional boundary? This isn't science fiction. This isn't philosophy. This is a serious line of research in theoretical physics connected to string theory, quantum gravity, and the nature of space-time itself. There are papers, equations, predictions that could potentially be tested. The idea is that our universe, all the depth, all the volume, all the three-dimensional reality we experience, might be a projection, a hologram. The actual fundamental description might exist on a two-dimensional surface at the edge of space-time, and everything we experience as depth is emergent from that. Now, does this mean you're not real? No. Does it mean your experiences don't matter? No. Does it mean reality is fake? No. It means reality is weirder than the concept of real versus fake. It means the question, how many dimensions does the universe actually have, might not have a simple answer. It might depend on which mathematical description you're using, which perspective you're calculating from. You might be a projection. Your depth might be an illusion, and somehow that doesn't make you less real. It makes reality stranger than the idea of realness. And here's why I love this, why it excites me rather than terrifying me. It means the universe is under no obligation to make intuitive sense to you. You evolved to throw rocks and find food and recognize faces. You did not evolve to intuitively understand quantum mechanics or general relativity, or the holographic principle. The fact that the universe is comprehensible at all, the fact that we can write equations that predict what black holes do, even though those equations lead to conclusions that violate common sense, is kind of miraculous. So, when something in physics sounds absurd, when it violates your gut feeling about how things should work, that's not physics being wrong. That's your gut being uncalibrated for regimes of reality it never had to deal with. Your ancestors never fell into black holes. They never moved at the speed of light. They never had to think about the difference between two-dimensional and three-dimensional encodings of information. You're okay with not intuitively understanding how your smartphone works, right? You use it anyway. You trust that the engineers and physicists who designed it knew what they were doing, even if you couldn't build one yourself. Black holes are the same. You don't have to intuitively understand them. You just have to trust the math, follow the observations, and be willing to let go of the stories that made sense before we had better data. So, let's bring this home. Let's make this practical. Let's talk about what you can actually do with all of this. First, learn to see what's invisible by its effects. You can't see black holes directly. They don't emit light. They don't reflect light. They're invisible. But you can see stars orbiting nothing, moving in ellipses around empty space, accelerating to speeds that only make sense if there's millions of solar masses concentrated in a region smaller than our solar system. You can see gas heating to millions of degrees around nothing, glowing in X-rays because it's rubbing against itself as it spirals inward. You can see space-time itself warping around nothing, bending the light from background galaxies into arcs and rings. You see the effects, and you infer the cause. That's how we know black holes are real. Not because we can see them, but because we can see everything they touch start behaving in ways that only make sense if they exist. Apply this to your life. What invisible forces are shaping you? What are you orbiting without realizing it? Maybe it's anxiety you haven't named yet. Just this low-level background hum of worry that affects every decision you make, bends every trajectory you take, but you've never actually stopped to look at it directly. You just feel its effects. Maybe it's a belief you inherited from your parents or your culture, something about what you're supposed to want, or who you're supposed to be, and you've been orbiting it your whole life without questioning whether it's actually yours. Maybe it's a pattern in your relationships. The same argument happening over and over with different people, the same dynamic playing out, and you keep blaming the other person without seeing the gravitational well you're creating. Here's your practice. This week, pick one behavior you do automatically, something you don't think about, how you respond to criticism, how you spend your mornings, what you avoid. Don't try to change it yet. Just watch it. Observe it like an astronomer watching a star's wobbly orbit. Ask yourself, what invisible gravity well am I circling? What am I orbiting? What's bending my trajectory without me noticing? You don't need to fix it. You don't need to solve it. Just see it. Make it visible by its effects. That's the first step. Second, embrace the horizon of your understanding. An event horizon isn't a wall. It's not a barrier made of stuff. It's just a boundary in space-time beyond which light can't escape back to you. It's a limitation of what you can see from where you're standing, not a statement about what exists. Every person has event horizons. Every field of knowledge has them. There are things you can't currently understand, not because you're stupid, but because you don't have the tools yet, the math you'd need, the experience you'd need, the perspective you'd need. And the mistake, the huge, costly mistake, is pretending the horizon doesn't exist, or worse, pretending that beyond it is nothing. Just because you can't see past it doesn't mean there's nothing there. I see this all the time. Someone encounters the edge of their current understanding and they shut down. I'm not a math person. I could never understand that. That's just not how my brain works. And they turn it into an identity. But horizons aren't permanent. They're just where you are right now. If you move, the horizon moves. If you learn new tools, you can see farther. If you change your reference frame, you might see around it. Here's your practice. Identify one thing you've dismissed as impossible to know or not worth understanding. It could be physics. It could be why your partner gets quiet sometimes. It could be what you actually want from your career. It could be how to cook a decent meal. Doesn't matter. Don't try to understand it yet. Just acknowledge, there's an event horizon here, I can't see past it right now. But that doesn't mean nothing's there. That doesn't mean I can't learn to see differently. Just naming it changes something. Just recognizing that your current limits aren't the limits of reality gives you room to move. Third, let Hawking radiation teach you about letting go. Black holes evaporate by releasing energy. They give back slowly what they consumed. They don't hold on to things forever. Even the most extreme gravitational well in the universe eventually releases everything it's been holding. You probably have something you're gripping too tight, a grudge, a version of yourself you've outgrown but keep trying to resurrect, a relationship that ended years ago but you keep replaying, keep analyzing, keep storing in your personal event horizon where it can't escape and can't transform. And you think holding on to it means it still exists, that if you let go, you're erasing it, you're admitting it didn't matter. You're consigning it to oblivion. But that's not what happens. Hawking radiation doesn't erase the black hole's history, it transforms it. The energy comes back out, just in a different form. Scrambled, yes. Changed beyond recognition, but not destroyed. When you let go of something, you're not destroying it. You're allowing it to transform. You're allowing the energy you've been storing to radiate back out into your life in new forms. Forms you can't predict. Forms that might not look anything like what went in. Here's your practice. Write down one thing you've been holding inside your event horizon. Something you won't release, won't let transform, won't let escape. Not to fix it. Not to process it. Not even to understand it yet. Just to name it. Because naming is the first quantum fluctuation. It's the particle that escapes so the rest can start evaporating. You don't have to become nothing. You don't have to lose everything. You just have to start giving back some of the energy you've been storing in your gravitational well. Let me tell you where we've been because we've covered a lot, and I want you to see the shape of it. We started with a name, black hole, that turned out to be a lie. Or at least, a very incomplete truth. We learned that these things aren't black. They're radiant, dynamic, mortal, and stranger than any metaphor we've invented for them. We saw that what looks like darkness is often just the edge of our current vision, that the most destructive forces in nature also seed galaxies, create stars, organize matter into structures that can support life. That information might never truly disappear, even when it seems swallowed whole. That time and space aren't fixed, they bend, they break, they play tricks depending on where you stand. And underneath all of it, we touched something deeper. Something about uncertainty not being failure. About the boundary between knowing and not knowing being where all growth happens. About permanence being an illusion we cling to, because change is terrifying. Here's what I want you to remember: not the equations, not the technical details. You are not the black hole. You are the accretion disk. You're the matter spiraling inward, heating up, radiating light precisely because you're under pressure. The constraints aren't destroying you. They're making you visible. They're making you matter. They're making you shine in wavelengths you didn't even know existed. The spiral isn't evidence of failure. It's not proof that you're broken or stuck or doomed. The spiral is the shape of transformation. It's what happens when you're caught between where you were and where you're going. And that friction, that resistance, that heat, is what makes you luminous. And when you feel like you're collapsing, like everything's being compressed into a singularity you can't escape, like the pressure is too much and you're going to implode into nothing, remember Hawking radiation. Remember that even the densest, darkest, most seemingly eternal things give back their energy eventually. You don't have to hold everything forever. You're allowed to evaporate slowly into something lighter. You're allowed to radiate energy and decrease your mass, your burden, your gravitational pull on your own past. You're allowed to transform completely into a form that doesn't resemble what you were. That's not death. That's not failure. That's physics. That's what the universe does with everything, including you. The universe doesn't end at the horizon of what you can see. It doesn't end at the boundary of what you can prove or measure or understand with your current tools. It keeps going, weirder and more beautiful and more alive than your current instruments can detect. So stay curious, stay humble, stay willing to be wrong for decades, and then change your mind when better evidence comes in. That's not weakness. That's what Hawking did. That's what every good physicist does. That's what every honest human does. And for crying out loud, stop calling things black just because you haven't figured out how to see them yet. Stop assuming that invisible means empty. Stop treating the limits of your current vision as the limits of reality. The black holes aren't black. They never were. We just needed better eyes, better tools, better questions. And once we got them, we saw that the darkest objects in the universe were teaching us about light all along. You've got black holes in your life, places that seem dark because you can't see into them, relationships that ended without explanation, efforts that seemed to vanish, versions of yourself that you can't find anymore. And you've been calling them black because you're looking with the wrong eyes. But they're not black. They're transformation engines. They're accretion disks glowing with the heat of everything you've been through. They're event horizons marking the boundary of what you can currently see, not the boundary of what exists. And maybe they're Hawking radiation slowly, quietly giving back everything you thought you'd lost, just in forms you haven't learned to recognize yet. If this shifted something in how you see yourself, the universe, or the weird poetry hiding in physics, let me know in the comments. Tell me what clicked. Tell me what you're still wrestling with. Tell me what black holes you're circling that you're ready to see differently. Subscribe if you want more of these deep dives where we take the stuff that scares us, the things that seem too dark or too complex or too final, and find the beauty underneath. Find the light that was always there, waiting for better eyes, and hit the like button. Not because I need it for my ego, not because the algorithm is a black hole and we're all just trying to stay in orbit long enough to be seen. Well, okay, partly that, but also because if this meant something to you, there's someone else out there who needs to hear it, someone else who's been calling something black that isn't. Someone else who's ready to see that darkness and light aren't opposites. They're partners in the universe's strangest, most beautiful dance. Thanks for spiraling with me. Keep glowing, keep transforming, keep questioning what you think is permanent. I'll see you in the next one.